This lesson is on linear and nonlinear patterns. So I have two patterns here. Let's take a look at both of these patterns. So the question is, what patterns can we find in these patterns? In order to do that, maybe let's start counting dots. So pattern 1 here. Term number 1, so this first little thing here, how many dots are there? Well, there's just 1. In the second term, how many dots are there? There's 3. In the third one, how many dots are there? 1, 2, 3, 4, 5, 6. And in the next one, if we count up all those dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 dots. Okay, not bad. What about pattern 2? How many dots are there? Well, in the first one, we seem to have 2 dots. Then we seem to have 4 dots. Then we seem to have 6 dots. And then we seem to have 8 dots. What is the difference between these two patterns? Well, they start with different numbers, they have different shapes, but what about the number of dots in the patterns? Do you notice anything about them? So, first of all, pattern 2, you might have noticed as I was doing that there is a little bit of a pattern in those numbers. What happens each term? Well, it seems to go up by 2, right? As I was doing that, you're probably like counting by 2s in your head, 2, 4, 6. So the next one would be 8, 10, 12, 14. We can continue the pattern, right? And it will keep on going. And that's pretty obvious. So that's interesting. Pattern 1, does it do this? Does it go up by the same amount each time? Well, let's try. Going up from 1 to 3, it goes up by 2, right? And then from 3 to 6, oh, that doesn't go up by 2. That seems to go up by 3. Keep on going. 6 to 10, well, we need to go up by 4 there. So what's the difference between these two patterns? One big difference is that this pattern, pattern 2, goes up by the same number each term. The same number of dots each term. And pattern 1 doesn't, right? There is a pattern here. It goes up by 2, then 3, then 4. So we can predict the next one is going to go up by 5, right? So there's going to be 15 dots. But the difference here that we're concerned with today is the difference between a linear pattern or a linear relation and a nonlinear pattern or a nonlinear relation. What we can do to see this big difference is graph both of these sets of points on a grid. So let's do that now. So I've just opened up a Desmos window here with some graph or tables that we can plug in, and it's going to plot the points. So for pattern 1, we see term 1 has 1 dot. Term 2 has 3 dots. Term 3 has 6 dots. Term 4 has 10 dots. And we said if we continued this pattern, term 5 would have 15 dots, right? So if we look at that, if we look at those points on the graph, what do you notice about those? Okay, well, before we answer that, let's try pattern 2. So I'm going to do pattern 2 in the blue, make blue points with them. So pattern 2, the first term has 2, then 4, then 6, then 8, then 10. 10. There we go. Okay. So a little bit confusing. You know what? Let me change the color to red. It'll be a little bit easier to see the difference between the green and the red. So let me hide that. So what you see here is that there are 2 sets of points. I can zoom in there, actually. Let me zoom in there so it's easier to see. So remember, the green represents pattern 1. And if you notice, the green dots, 1, 2, 3, 4, 5, 6, there are the dots. If we were to connect those, we couldn't connect them with a line. It's not a straight line. You might notice it sort of curves like that, and it would continue up like that if we were to connect them. But if you look at the red dots, this one is a red dot here, you just can't see it. If you look at the red dots, you took a ruler and you tried to connect them, it would make a straight line, and it would continue on forever. So you'll notice the difference, the big difference here that we're concerned with in this lesson, is that pattern 1 did not sort of have the same number it went up by each time, and when you graph it, it does not make a line. Pattern 2, it went up by the same thing each time, and that formed a line. So what we do is we call pattern 2, we call this a linear pattern because it forms a line when you graph it. And pattern 1 we call a nonlinear pattern because it doesn't form a line when you graph it. Okay, so that's the big distinction for today. Let's do a few example questions. So here we're asked, can you prove if each relation is linear or nonlinear? So I'm going to do the first example. This is similar where we have term number and number of dots. So pretend it's a pattern. You can't see the pattern, but let's pretend I've created this table for this pattern. Is this a linear pattern? Well, in order to check if it's a linear pattern, I'm going to see what it goes up by each time. So the number of dots from term 1 to 2 goes up by 5. From 2 to 3, it goes from 10 to 20. That goes up by 10. Then from 20 to 40, it goes up by 20. 40 to 80 goes up by 40. 80 to 160, ooh, that goes up by 80. And we also notice over here that the term number is going up by 1 each time, right? It's important that that's going up by the same amount each time as well to see if the pattern is linear or not. But when we look at the number of dots in the pattern, it's not going up by a consistent amount. It's not going up by the same amount each time. So when we were to graph this, if we were to graph this, we would see that it would form a curve. It wouldn't be a straight line. So this is nonlinear. Now, I want you to try your turn. See if you can figure out linear or nonlinear. Pause the video now, try it yourself, unpause when you're done. So you should see that it goes up by 3 each time, and the term number just goes up by 1 each time. So when that's the case, this is linear, right? Because the amount it increases by each time is the same each time. Okay, so if we were to graph it, it would form a straight line. So now what I want you to do is I want you to try these 4 questions below. Now, I don't just want you to put an answer down. I want you to actually explain it yourself, like in the space that you have there. Make sure you've shown your work. So showing your work, an example of showing your work is something like this, right? Where we showed that it went up by not the same thing, or it went up by the same thing to prove if it's linear or nonlinear. So I want you to try those 4 questions now. You can unpause it. When you unpause it, I will reveal my solutions to this. Okay, so here's me showing my work. For the first question, it's a little bit hard to see, but it does go down by 17 each time. So the way you can find this if you're not sure is you always do the bottom number minus the one on top. So 93 minus 110 is negative 17. 76 minus 93 is negative 17. So you see there's a consistent number each time. And also on the left, it's a consistent number each time. It's every 2 months that they're doing it for. So because it goes down by the same amount each time, it would be considered linear. And one last thing you can do with this is you can actually find the rate of change. Remember how to find the rate of change? It's just the change here divided by the change here, right? So the rate of change we can calculate when it's a linear relation. So the rate of change would just be negative 17 divided by 2, which would be negative 8.5. And the units there would be, amount owed would be dollars, so it would be dollars per month. Right, because this is negative $17 and 2 months. Right, so we could find the rate of change. You can only really find the rate of change for a linear relation because it's not going to be the same for a nonlinear relation. Okay, so let's go to the next one. You'll notice here that the time goes up by 30 minutes each time, which is fine, that's consistent. And the distance goes up by 5, then it goes up by 6, then it goes up by 7. So is that linear or nonlinear? Well, there is a pattern, but these numbers are not the same. It doesn't go up by the same thing each time. So this is actually nonlinear. And another reason why is because if you would look at this, if we were to find the rate of change for each one of these, we would do 5 divided by 30 to find the rate of change for the first 30 minutes. 6 divided by 30, 7 divided by... We get a different rate of change for each value that we use. So that's another way to say that it's nonlinear, is that the rate of change is not the same. Okay, moving on. Third question here. Here I had to count the dots. with the dots were 1, 4, 9, 16. That was the number of dots. And you'll see, to get from 1 to 4, we had to go up by 3, then we had to go up by 5, then we had to go up by 7. Again, there's a pattern here, but are all those values the same? No, so it is nonlinear. And lastly, we have this pattern, 2, 4, 6. Obviously, this goes up by 2 each time, right? So if it goes up by 2 each time, we would say that it's linear. And in this case, the rate of change is just going to be 2 because it goes up by 2 for each term number increase. Okay? So that is the difference between linear and nonlinear relations. Okay? Try the rest of the problems in this handout.